All right, so we are on notes 5-3 for geometry. Today's date is Tuesday, January 28th, 2020. We're talking about special right triangles, and man, this is one of the fundamental things that you need to know in all of mathematics. Like, if I had to pick one lesson from all of geometry that's going to be on the SAT, that's going to be used again in Algebra 2, that's used again in pre-calculus, that's used again in AP Calculus, it's this lesson. You really need to have these down. I have a poster already on the top left of all the stuff that you need to have memorized from this lesson, so if you need to reference it. I know it's not the easiest. Even I have 20/20 vision, I can barely make out the top poster, let alone the bottom poster. This is, say again?
I have 30 vision.
Yeah, all of that stuff is from the notes today. This is super, super important. Even if you have the proportions memorized, knowing how to manipulate the proportions in order to find your missing side lengths is the hard part. So I want 110% focus today. As a mathematician, that makes me cringe. I need your full effort today, 100% effort today. Question, Andres?
It's the off task.
No, we're in the middle of the lesson. You have to wait now. Quiet Sam for the objective. Julian had it slightly before Jessica.
Use the ratios of special right triangles to find missing side lengths.
There it is. All right. So it's important to know where these special right triangles come from. If you guys can pass around Julian's card so it gets to the inbox, I'd appreciate that. Where does the 45, 45, 90 triangle come from? And the answer is it comes from a square. Nice and simple. You'll be hearing the words 45, 45, 90 and 30, 60, 90 a lot throughout your high school career. So what does that even mean? 45, 45, 90? Does anyone want to take a shot at what that means? Andres, your card?
So I believe that 45, 45, 90 are the angle, or they're the angles of the triangle.
Yep, and you can see it down here. I have a 45 angle, and this is a 90-degree angle. And for the same reason, we have a 30, 60, 90. So those are talking about the angles of the triangle. Which means if I have a triangle that's 31, 60, or 59, 90, I can't use these. They only apply when it's exactly these angles. And you might be thinking to yourself, well, shouldn't we be learning a bunch of these? Why are we only learning these two? These two occur naturally a ton of different places. So they come up very, very frequently, and that's why I want you guys to know them. It's like a shortcut. Okay, so we have a square, which means if it's a square, these two lengths must be the same. Go ahead and add these two tick marks to your square as well. I want to be able to figure out what these ratios are. If I say maybe this is x, then what is this length right here? It will 100% always be the following number. We don't know what that is. So if this is x, this also must be x. That's kind of self-explanatory. But then what is this length right here? So I'm going to come back up here to my square, and I need to think about this. So this is x, and this is x. I'm going to use the Pythagorean theorem that we've been talking about over and over for the last two lessons and figure out this length right here. So let's call that length, I don't know, what should we call it? Heart? Y? Z?
C.
C? Okay. All right. Can someone do a quiet raised hand and tell us how to set up the Pythagorean theorem for this one? Gunnar? I'll take your card too.
It's something equals c squared.
So yeah, something equals c squared. I do the leg squared plus the other leg squared.
Both be x.
They're both x, yeah, so
Okay, so x squared plus x squared 2.
is equal to c squared. Yeah, thank you, Gunnar.
2.
And what's unique about this one is since I have both x squared, I can say, oh, how many of those x squareds do I have? I have 2 of them. 2 x squareds is equal to c squared. All right. I'm going to choose a specific path because it's going to be the easiest path of them all. I'm going to decide to square root right now. I'm trying to solve for c, right? I don't care if I solve for x. I want to solve for what this missing length is. So I want to isolate that c. What am I going to do to both sides right now to isolate c with a quiet raised hand? Yeah, Jenny, you have your card still? There it is. Square root both sides. And I now have the square root of 2x squared is equal to just c. So I can rewrite this square root of 2x squared specially. So whenever you have the square root, I can break them apart as long as they're still being multiplied. I am allowed to do that. So I'm going to now rewrite this as the square root of 2 times the square root of x squared. That's the same thing as long as they're being multiplied by each other. Question, Gunnar.
Why when you square root c squared, do you cancel out the squared but not another one?
Yeah, that was a teacher error if you want to log it.
It was?
Yeah, I meant to leave it there. Like you're wondering why that square was not there? Yeah, so these cancel out the square, so that's why I have c, and this should just still be x squared. All I needed to do was split them apart. And that's still being set equal to c. And we're almost done. I can simplify this. If I have the square root of a square, what is my final answer here? C is going to be equal to what? Quiet raised hand. What is the square root of x squared? Square root and square, special things happen in that case, just like we had over here. What did we do? Jose?
Cancel out.
They cancel out. So what's our final answer?
2x.
So I agree that's x, and over here I have still the
Oh, that's
square root of 2. Yeah, so square root of 2 times x, and more formally, we normally write this as just x square root of 2. Normally we write the radical after the non-radical. All right, perfect. So we know that length. We can come down here and label our triangle. If this length is x, this length is x, therefore this last hypotenuse, that is x square root of 2. And that's something that you need to burn into your brain. Memorize this. Think about it before you go to sleep each night. 45, 45, 90 triangle goes x, x, x square root of 2. I'll show you an example problem very, very soon. But let's go ahead and discover the origin of the 30, 60, 90 triangle. And actually, before we do that, let me talk about how to manipulate this. So in order to move from x to x squared root of 2, I need to multiply by what? Quiet raised hand. Nice and easy answer here. To get to x, from x to x squared root of 2, what am I really multiplying this x by? I'm multiplying by, who has it with a quiet raised hand? Monse. What am I missing to get from x to x squared root of 2? I'm missing just the, you have to say it though. Say it. Square root of 2. Square root of 2, perfect. So everyone write this down. In order to move from the leg to the hypotenuse, I need to multiply by the square root of x. So my multiply symbol is the dot. If you want to use the tiny x, you can. And if I want to do the reverse of that, if I want to move from the hypotenuse to either one of the legs, I'm not going to multiply by the square. Wait, did I just write square root of x?
Teacher, I caught it first though. No, you didn't.
Square root of 2. I should have let you guys catch it. If I would have let you catch it, then you could have gotten the XP. That's my bad.
XP? Oh, that's teacher. That's teacher.
If it's a math teacher error, then I'll give it to you.
But you said XP.
XP is part of math.
That's history. We don't talk about it anymore.
So, square root of 2, what operation am I going to be doing in order to get rid of a square root of 2 from x square root of 2 to just normal x? It's not multiply anymore. Who has it with the quiet raised hand? It's the opposite. Come on. Who's got this? Cohen, you've got this. What is the opposite? Yes, there it is. Everyone have this written down. It seems really simple. Oh, yeah, just add on a square root of 2, multiply by the square root of 2, get rid of it, divide by square root of 2. This will help you immensely on the homework tonight. All right, let's move on to the origin of a 30, 60, 90 triangle. So to move from the hypotenuse to either one of the legs, I'm going to divide by square root of 2. To get from any of the legs to the hypotenuse of a 45, 45, 90, I multiply by square root of 2. Have these operations written down on your notes. They will help you, I promise. All right. Now let's talk about the 30, 60, 90 triangle. It comes from an equilateral triangle. Can someone give me a quiet raised hand and tell me what the definition of an equilateral triangle is?
I was raising my hand before the hands were raised.
Someone that still has their card. Andres, you don't have your card anymore. Can you please turn it in?
Can I make this amazing shot?
No, because that will be breaking the classroom rule. Eder, yes. Equilateral. I'll give you a hint. Equal somethings.
Good or nosy?
I know quite well, actually.
I'll give it to him. Quite well,
Yes.
actually.
No, you don't get to give it to someone.
What? You let the cone do that yesterday.
What is equal about this triangle? You can talk about some part of the triangle.
Sides, they're angles.
Yeah, all the sides are equal. Or I could have said, what, Andres?
They're angles.
Yes, you can see equal angular or equal sides. So let's go ahead and write this down. This tick mark, and I guess we'll put it right there. All of those sides, as Eder said, are the same, and all of these angles are the same. That is what it means to be an equilateral triangle. So let's go ahead and call this half right here, x. I can figure out what this length must be. With a quiet raised hand, what must this length be if half right here to here is x? What is this whole piece? If that was x, how do I get the whole piece? Quiet raised hand, yeah, cone. We took half of it to get x, so I double that to get the full length, cone.
X times 2.
There it is, x times 2, or 2x. The hypotenuse is 2x, the leg is x. So I need to come back down here and label the same thing. If this is x, this must be 2x. And then I need to figure out what this remaining side length is, that leg. So we have to do a bit of math. Let's go ahead and call this lowercase b. I need to figure out what the height of that red dotted line is, or the remaining leg of the 30, 60, 90 triangle is. We're going to have to do a little bit of math to discover what that is. Again, I need someone to help me set up the Pythagorean theorem to solve for b. Who's got it? So eager. And I want to call on you guys. I need to call on someone that still has their card,
Oh,
though.
we're so eager to do math.
Oh, Josie, yes, you have your card. Leg squared plus leg squared equals hypotenuse squared. You've got this, Josie. I believe in you. So you can think of this.
X
Yeah, x squared.
squared.
So far, so good?
Squared plus X squared.
Careful. Equals. Equals what squared? The hypotenuse squared, right? What's the hypotenuse? Is it 2x or x? Yep, so that 2x squared. Perfect. And be careful when I square this, everyone. Put parentheses around that. I'm squaring the entire quantity of 2x. I'm not just squaring the x, I'm squaring the 2 and the x. All right, this step is going to be tricky, but I'm hoping that we can get it. Who can turn that right-hand side into something else? I need to square the 2x. So who can square the 2x? And I already gave you the hint. You need to square the 2 and x. Has everyone gotten in yet?
Maybe.
Do I have everyone's cards?
Maybe.
You guys need to turn in your cards so that way I can keep track better. Whose cards do I not have?
Montserrat.
I think I got Monsters.
No, you didn't.
I did. I think I have. Oh yeah, Fernando, go for it.
Oh, man. Wait, what am I doing?
Square 2x. Square the 2, square the x.
So, like, you're gonna square, right?
Yep.
And then, like, the power 2 cancels off, right?
No.
I don't even know.
What's 2 squared?
2 squared?
Yeah.
What is it?
Yes. What is 2 to the power 2?
4.
4. Okay. And what is x squared?
X to the power 2, yeah.
Yeah, x squared.
What about, so that only, if you take the square root of a square root, then the square roots will cancel out.
If you take a square root of a square root, like that,
Yeah.
the square roots do not cancel out. The only thing that undoes a square root is a square. A square and a square root will cancel each other out.
So if you square a square root, then both of them cancel out, and then the number that's left is, yeah.
Yes,
Okay.
you're correct. All right, and then on the left-hand side, just copy it down. It's still x squared plus b squared.
But why is it still 4x squared? Wait.
So the property that we're invoking is if I have a times b quantity squared, I can take this square and apply it to both these insides, so it's a squared times b squared. That's what we just did over here.
Okay, makes sense.
All right, so zooming in. I now want to have all of the, I want to solve for b, right? That's the unknown. So I need to get rid of this x squared. What am I going to do to both sides? I'm just going to call on first hands now because we've got everyone in. Andres.
So you're gonna take the square root of it?
I want to move this x squared over first.
Oh, you're gonna minus x squared to on both sides.
Minus x squared, minus x squared. And how many x squareds do I have on the right-hand side now?
You have 3x squared, and on the other side you have b squared.
Perfect. Next step. What am I doing? Gunner.
Square rooting it.
Square root both sides. And what do I have on the left-hand side now, Gunner?
Square root of b squared.
Be careful, those cancel out. What is the square root of anything squared? B. There it is.
It's just regular
B.
b.
And then, Gunner, again, I'm going to separate this into two parts. That part and that part. Can you separate both of those for me?
It would be 3
Square root of 3 times.
square root of x squared.
Perfect. And then, quite raised hand to simplify my final answer. The same two people over and over. Can I get one more? Sergio? Can you do this one?
Nah.
Sergio, just do this one for
We
me.
haven't called on surgery.
I haven't. See, this is why you guys need to turn in your cards. I can't tell.
I think you should hear it.
What is the square root of x squared, Sergio? X. And I have the square root of 3 left over. Thank you, Sergio. So I can come down here on my final diagram and say my leg is x squared of 3. X square root of 3. And then before we finish and go and do our actual problems, let me go ahead and talk about how to manipulate this thing. Think of this as a sharp corner that you're not allowed to go over. This is a sharp corner, it's deadly. So you can even make a note and say this is deadly. It's a deadly sharp corner. There's no way, well there is a way, but I'm not going to show you the way to go over that sharp corner. You can only go over the non-sharp corner and this other non-sharp corner. So there's an operation to go from x to 2x. What do I do? What is the operation? Very similar to what we did up here, but it's even easier. Instead of multiplying by square root of 2, I do what? Quiet raised hand here. Andres.
You divide by the square root of 2?
To get from x to 2x.
Oh, 2x. Okay, so to move x to 2x.
To what do I have to do to x? What operation do I have to do to x to get to 2x?
Multiply by the square root of, yeah, 2. Multiply the square root of 2.
No, that's not a square root of 2 right here.
Oh wait. Multiply by the square root. Or just square root it, or just multiply by 2x.
Multiply by 2.
Okay, 2.
Multiply by 2. Does everyone see? If I multiply x by 2, I get 2x. And then the reverse operation of that, if I want to go backwards, I do what operation? With a quiet raised hand. Instead of multiplying by 2, I do what, Jose? Divide by 2. And then the other sharp corner that I have, if I want to go this direction, to get from x to x squared of 3, I do what operation? Anyone? Gunner.
Divide.
Careful. I'm adding on, so I'm going to
Add.
not really add.
Good job, baby.
Multiply by,
I said that.
Keep on thinking.
by what?
Take your time.
Gunner. Multiply by,
Or,
I already have an x, I'm missing a
3 square root is 3.
square root of 3, thank you.
good job, good work.
And then finally going the opposite direction, if I need to go from the long leg, can we all label this also? I don't know why people, last year people had difficult knowing that that was called the long leg over here. And this is the
Long leg?
short leg.
Well, wait, how?
And this is the hypotenuse. To get from the long leg to the short leg, to go in the yellow path, I do what operation, Andres?
You divide by the square root of 3.
There it is. All right, so we have these diagrams. These are going to be invaluable to us on the homework. Let's actually do some example problems. Make sure you have this diagram copied down exactly.
Good job.
You need all 4 of those operations. Again, do not go over the deadly sharp corner unless you know what you're doing. There's, of course, a shortcut, and I'm not going to restrict anyone, but just be careful. Just know that you don't really ever go over the sharp corner because you have to do two operations at the same time.
What's the shortcut?
The shortcut is if I want to move from x squared root of 3 to 2x, I multiply by 2 and divide by square root of 3 at the same time. That's how you do the deadly sharp corner.
So multiply by
Which
what?
is the same thing as just doing this and this.
Mr. Sindel, can you please repeat that, please?
Yes, so if I want to go over the sharp corner, it's the same thing as going over the two dull corners at the same time.
But like, what would be it, like multiply by what and what? And
So I multiply by 2 right there, and I divided by square root of 3. So I went this direction. I did the yellow direction.
so what about the other, when you go through the deadly?
Oh, if I want to go through the deadly, yeah, that is the deadly corner. Going like that to that is the same thing as going that to that.
So, okay. Multiply by 2 and divide by the square root of it.
Exactly. And if I want to go the other direction, I...
Wait, I have a question.
Okay.
So like,
Gunnar, why are you out of your chair?
because I have to like write it because it's kind of complicated.
Okay.
If this is a deadly corner, this one right here, these ones are sharp too. Why aren't they deadly?
Those are not as sharp as the deadly corner.
Doesn't make sense.
It's not
They
as sharp
basically
as
look
as
exactly the same.
Wait,
Just
Mr.
the angle's
Sindel?
different.
Gunnar, it's not
Can
as
you
sharp.
erase that from the board, please?
Yes, I can.
It's just a way to help you remember, be careful of going over the sharp corner because it takes two operations instead of one.
So when you're going over the sharp corner, do you divide and multiply by the number that's on the hypotenuse?
Exactly, yeah.
Like,
Divide by your
Well, you
hypotenuse.
multiply by the hypotenuse and divide by this to get rid of this square root of 3.
oh, okay, so you divide by the square root.
Divide by square root of 3, multiply by 2. Because you need to get rid of the square root of 3 and get a 2. All right, let's do some example problems.
So those weren't even real problems?
Those were how to do these problems. Now I'm going to actually do the problems. So, I'm giving you this triangle. I'm telling you that, I guess we have to assume because I didn't write it down. That's my bad. We'll assume that this is 45 degrees. Let's assume that this is 45 degrees. If we assume that those are 45 degrees and we also have that 90 degree, I can tell you the answer. X is equal to what with a quiet raised hand? I just take that number and do what to it? Gunner.
45. I don't actually know.
Okay, Andres.
5 squared. This, yeah, 5 squared.
No, but good guess.
Square root of 5.
Okay, so again, our operation up here. We said if I want to move from here to here, I multiply by square root of 2. If I had a 5 here, the answer is 5 times the square root of 2. The answer is 5 square root of 2. The answer is 5 square root of 2. Again, the operation that we just used was we moved from here to here, so we multiplied by the square root of 2.
How'd you get square root of 2?
Square root of 2 came from all the way back here. We multiply by square root of 2. Here are your proportions. If this is x, if this was 5, then this is going to be x square root of 2, 5 square root of 2. X in this case is 5. This was 5, this was 5, this is 5 square root of 2.
So is that the same triangle as the one number?
Exactly the same triangle, but this one was just a variable triangle. This applies to all 45, 45, 90 degree triangles. But in the case where this is 5, that's one specific triangle in example number 1, and I change all the x's to 5s. All right, let's try another one.
So that's the shortcut way?
This is
to do it?
This is, well, yes, it's all of the special right triangles are shortcuts. Let's try another one. A 30, 60, 90 triangle. Oh, I need to move, I have an 8, and I need to find x. I need to move from 8 to x. What operation do I do? To get to x, x is going to equal what? With a quiet raised hand. X is going to equal, Sergio? Divide by 2 and you get 4. Done. Box it. I divide by 2 to get from the hypotenuse to the short leg of a 30, 60, 90 triangle, to get from the hypotenuse to the short leg of a 30, 60, 90 triangle. I'm doing this direction. I'm dividing by 2. So I come down here and I say 8 divided by 2 is 4. Done.
That's it.
That's it.
That simple?
That's simple. Question, Gunnar.
Why did it get so simple all of a sudden?
Because I showed you all the complex math so we can have a shortcut now. We've now created a shortcut to do these problems.
You're good.
And now you're about to say, wait, why is it so hard? All right, so example number 3.
Wait, why is it so hard? Wait.
Here we go. Example number 3. Now I'm giving you the hypotenuse, and I need you to get to either that leg or that leg, which is the same leg because it's a 45, 45, 90 triangle. So what operation do we do to get from 6 to that leg? Andres.
So you have to do multiply by 2 and divide by the square root.
For a 45, 45, 90 triangle, right here, if I want to move from the hypotenuse to the leg, what operation do I do right here, Andres?
Divide by the square root of 2.
There it is. Divide by the square root of 2. So everyone write it down. We are down here dividing by the square root of 2. If I ever go from the hypotenuse to a leg of a 45, 45, 90 triangle, it's always going to be divided by square root of 2. So the answer is 6 divided by the square root of 2. So while that's mathematically correct, it's not simplified. So I can't box it yet. There's a way to get rid of rationals that are in the denominator. Whenever you see a square root in the denominator, you need to make sure that there isn't a square root in the denominator. The way that you get rid of that is by doing the following. But before I do that, I want to make sure everyone's on the same page. Square roots on the bottom, bad. We're good on that, right? All right, so to get rid of it, I'm going to multiply by whatever the denominator is. Square root of 2 by the square root of 2. If I had a square root of 3 on the bottom, I'd multiply by square root of 3 over square root of 3. If I had a square root of 5 on the bottom, I'd multiply by square root of 5 over square root of 5. Whatever that denominator is, I'm going to multiply by that over itself. Because I'm still multiplying by 1, it's still the same number, and check out what happens. When I do that, the top is now 6 square root of 2 because I just squished those together. But the denominator is going to have something interesting happen. If I have the same number twice, like if I had 3 times 3, that would be 3 squared. So if I have square root of 2 times square root of 2, that's square root of 2 squared. Oh, we know what happens when we have a square root and a square. What happens? Quiet, raise hand. Andres.
They cancel out.
They cancel out. So you can come up here and say, yep, those are gone. Yoink, yoink, gone. And our new fraction is 6 square root of 2 over 2. But wait! There's more!
Good.
Billy Mays here. There's more because now 6 and 2 can be reduced. 6 divided by 2 is just...
5.
You guys can shut that one out. You guys know this one.
57.
This is now 3 square root of 2, and there's our final answer.
Are you sure?
I am 100% sure.
How do you know?
I smoke cotton.
Because there's no square root in the denominator, therefore I am done. I have simplified the fraction as much as possible.
So to not believe anything, so don't believe it.
Yeah.
I have used the rigorous rules of mathematics to show you this. You should now believe me.
I don't believe
Well, I don't know.
Is this the final answer?
That is the final answer. We have boxed it.
Are you
smoke
accredited
half.
mathematician by the mathematician?
So it is a valid question to ask, why do we care about square roots in the denominator? And I have a personal belief, but I don't know if it's justified. I think that back in the day, back when dinosaurs roamed the world, but back when we were doing calculations without physical calculators, we had a giant book of what are all the square roots. We had a book of what is 3 square root of 2, and it would show you out to 10 decimal places what that is. It would tell you 73 square root of 2, 73 square root of 5. It's a giant book of just square roots. You would have had to have a second entire giant volume of divided by square roots, and then another volume for times square roots. So in order to be able to only use one giant book, we have the way to simplify into this. That's the only reason that I know.
I don't.
It's kind of ridiculous, and I have a poster or a comic up there explaining why it's ridiculous.
Where? Which one?
You'll eventually find it later. Sit down. We're not going to be off task. Let's try example number 4, which is the hardest of the 4 examples, because not only do I have to do the same math that I just did right here, but I have to do 2 operations because I have to do 2 steps. I'm not supposed to go over the sharp corner unless you know what you're doing. So I'm going to go over each of the other corners, which is the same thing as going over the sharp corners. To get from 9 to x, I'm first going to go over this 90-degree angle. So to get from the long leg to the short leg, what is the operation? Go back to the front side or memorize it, right? Jose, what is it?
Divide by like the square root of 3, right?
Exactly. Divide by square root of 3. And that's going to be 9 over square root of 3. Oh no! We have a radical in the denominator.
That's good, right?
That's bad. Let's get rid of it. So here's our scratch work.
You could have avoided this if you went through the top.
No, you'd have the same problem in the top. 9 over the square root of 3. Quiet raised hand. What am I going to multiply the top and bottom by? Yes, Sergio.
3 or
Square root of 3. Yeah, square root of 3 over square root of 3. And what's that going to become, Sergio?
the answer.
What is the numerator going to be, Sergio?
9, 3,
And on the bottom?
3.
Just 3. We're skipping a step here because the square root of 3 times the square root of 3 is 3, because the square root of 3 squared is 3. And then finally, my last step, simplify the 9 and 3, Jose,
Divide by 3.
and you get,
3. Square root of 3.
there it is, 3 square root of 3. And I'm not going to box that yet, because that's just this. So I'm going to say, okay, that's good, let's cross you out. You're really 3 square root of 3.
It's confusing.
There's a shortcut if you can find it for dividing by square roots. Does anyone see it?
Why couldn't we just do this?
9 over square root of 3 turned into 3 square root of 3. 6 divided by square root of 2 turned into 3 square root of 2. I'm going to leave you with that. I'm not going to tell you the shortcut. You have to find it out on your own. But there is a shortcut. Go ahead and find it.
Good, what's the shortcut?
And finally, the last operation that we have to do is go from this 3 square root of 3 to x. What operation do we do to get from the short leg to the hypotenuse? We do what? Only one person knows. 3 people know. Okay, Gunnar.
I'll just raise my hand so more people that multiply.
By.
3 or that one. 3.
No.
2.
By 2. So multiply 3 square root of 3 by 2, Gunnar. What's that? 3 times 2?
3. I don't know.
3 times 2 is 6. So
Yeah.
6
So
square root of 3 is our
6
final answer.
Well, I didn't know if I was supposed to like do both of them.
Right, yeah. And it is a review that we need. Whenever we multiply by a number, if I multiply a non-radical, then I squish this 2 with the non-radical. If I multiply by square root of 3, the radicals would multiply. Radicals and radicals get multiplied. Non-radicals and non-radicals get multiplied. So for example, I'm going to come over here to the sidebar to give you what I think to be a solid example. If I have the square root of 2 times 3 times the square root of 3 times 7. The way that I do this is I do all the non-radicals multiply together. That would be 21. And I do all the other radicals multiply together. 2 and 3 form 6. 21 square root of 6. Whenever I do multiplication, multiply the radicals together for the radicals. Multiply the non-radicals together for the non-radicals, you have your solution. So when we multiplied this 3 square root of 3 by 2, the 2 and the 3 multiplied together to get 6, and I left the square root of 3. I have no other multiplying by radicals, so I leave the square root of 3. And our final answer is 6 square root of 3. I could have even done a harder one for you guys.
What?
I could have done, I'll give you, and you'll see this on Khan Academy too, this hypotenuse will be 12 square root of 7. And you need to move around knowing these operations. But knowing how to do the operations is almost enough to solve these problems.
Trying to go back to math.
All right, that concludes the lesson. Give me a fist of 5 on our objective. So our objective today was, can you use the ratios of special right triangles to find missing side lengths? How well can you do those examples? Let's go around the room. Jenny. 3, 0. Come on. 4, 2, 3, 3.5. 2. Just hold up a solid number of fingers, guys. 2, 3, 3, 3, -1, 4. All right, that concludes our lesson.